Alright, let's start by the first problem, how to divide and simplify. So I would like to factor first. The only one that I can factor is 6c plus 54. So let's go ahead and try to factor this one. We have c plus 9 divided by c minus 3. Instead of division, I want to multiply and do the reciprocal of the second one, so that 6c plus 54 will be in the denominator. Notice that I can pull out the 6 as a common factor, and I'm left with c plus 9. Because 6 times c will bring back 6c, and 6 times 9 will bring back the 54. And I'm going to put c minus 9 on the top again because I'm dividing, I multiply by the reciprocal. Notice that c plus 9 and c plus 9 will cancel. C minus 9 over c minus 3 times 6 would be the final answer. So that would be c minus 9 over 6 times c minus 3. I cannot simplify anymore because here we have no product between them. There is a subtraction. In order to simplify, these should be multiplied by each other. Okay, let me put the answer here. So the answer should be a fraction. I have c minus 9 in the numerator. In the denominator I have 6 times c minus 3. Okay, so again, all I did here is multiplied by the reciprocal. I flipped this fraction, put the c minus 9 at the top. On the bottom, I took 6 as a common factor. And you notice if I multiply 6 times c, I will get 6c. If I multiply 6 times 9, I will get 54. So I haven't changed anything. But here, the c plus 9 will cancel. This is c minus 3, and this is c minus 9, so they cannot cancel. They're not exactly the same. And 6 also will not cancel, so that would be the final answer. Let's move to the second question. Here we have to divide, but we can now factor these two, because here we have y as common factor. So let's write as y common factor, and we are left with y plus 5. Again, if you distribute the y times y is y squared, and y times 5 is 5y. So I haven't changed anything. Here we have a trinomial. We want the product to be -5 and the sum to be 4. The two numbers are 5 and 1. So let's make sure we do this right. This is y and this is y. We want the product to be -5, so one of them is going to be 5, one of them is going to be 1. Now this is plus 4, so we're going to choose plus 5 and minus 1, because remember the outer, let me just do this. Okay, so it's going to be minus 1 here. The reason this is right, because this is the outer is 5y and the inner is minus 1y, and 5 minus 1 is plus 4y. So that's how you confirm that you did this right. First of all, y times y is y squared. -1 times 5 is -5. The inner term comes from the outer, which is 5y, minus 1y, which is 4y. And how did I get those numbers? Again, the product is -5. -1 times 5 is -5. Their sum is 4. -1 plus 5 is 4. Okay, now remember, when we divide, we multiply and do the reciprocal. So y plus 1 will go in the numerator and y will go in the denominator. And let me try to simplify. This y and this y will cancel. This y plus 5 and this y plus 5 will cancel. And the final answer is y plus 1 over y minus 1. And let's try to enter the answer here. So we have y plus 1 over y minus 1. Let's do the next question. The next question, we have to subtract. And when you subtract, you have to have that same denominator, right? Every time we subtract fractions, we have to have the same denominator, which is not true in this case. This is 11y and this is y. So all we have to do, change this to 11y, but we have to multiply up and down by 11. So that would be 11y minus 11 times 5 is 55 over 11y. So all I did, I multiplied up and down by 11. 11 times y is 11y. If I multiply this by 11, I'm going to get 11y. 11 times negative 5 is negative 55. The second one, I'm not going to change it because it has already 11y in the denominator. But something important here, I need to distribute the negative sign to both because that minus sign is sitting outside, so it has to be distributed. So let me put them under one radical, and with 11y in denominator, the numerator of the first one is 11y minus 55. The second one, if I distribute the minus sign, I get negative 5y, and negative times negative is positive plus 1. And therefore the final answer would be 11y minus 5. Okay, that would be 6y. Negative 55 plus 1 is negative 54 over 11. Notice I can take 6 as common factor here, but it's not going to help because 6 and 11 won't cancel. So that would be the final answer. So 11y minus 5 is 6y, minus 55 plus 1 is negative 54, and 11y in the denominator. Let's enter this one. So that would be a fraction first, and then we have 6y minus 54 divided by 11y. That would be the final answer. Let's move to number 4. Here again we need to subtract. We don't have the same denominator, but if I multiply this by 7 up and down, I'll get a 49. Let's do that. So here all we have to do, keep the first fraction or rational expression the same. Second one, I need to multiply up and down by 7. So that would be 7c, 7 times 9, 63, over 7 times 7, 49. So to make the same denominator, I multiply up and down by 7. That would be 7c, 7 times 9, 63. Notice the minus also should distribute both terms. Let's put them under the same 49 denominator. The first will not change, c minus 9. The second becomes negative 7c minus 63. Let's subtract. c, 1c minus 7c is negative 6c. Negative 9, these are like signs, so we're going to add them. And 63 plus 9 is 72, but it's a negative 72 because like signs we add and save the sign. Again, this problem, I can take 6 as a common factor, but 49 is only divisible by 7, so nothing is going to be helping. So let's keep it this way. Let's see if we have this answer somewhere. Negative 6c, negative 72 over 49, it would be A, right? Negative 6c, negative 72 over 49, it would be A. All right, let's move to the next question, number 5. On number 5, I have to subtract. Again, you notice that this is 7yq squared, this is y squared q. So what I need to do here is multiply here by y. If I multiply here by y, I would get 7y squared. If I multiply here by 7q, I will get 7y squared q squared. So the first one, all we have to do, multiply the first one by y, and that would make it the top 2y squared. Multiply this one by y would be 9qy over, multiply this by y, 7y squared q squared, minus. The second one, I need to multiply by 7 and q, so I make the same denominator. So let's multiply by 7q. If you multiply by 7q, you would get 7y squared q squared. Now we have the same denominator. Let's multiply the top by 7q. 8 times 7, 56, times q would be yq, minus 7 times 3, 21. And if I multiply by q, that becomes q squared. So now I have the same denominator. Let's see if I can subtract the numerator. So I have 2y squared plus 9qy minus, remember the minus should be distributing here, 56 yq or qy the same. And minus times minus is plus 21q squared. And of course we're going to keep the same denominator, 7y squared q squared. Notice that 2y squared, 21q squared, these will not combine, so we're going to keep them. But these two are like terms because they have qy. And what is 56 minus 9? That would be 47, right? 47, is it minus or plus? It would be minus because this is more negative. So this would be minus 47 qy, and the denominator will not change, 7y squared q squared, and of course looks exactly like this one, 2y squared 21q squared minus 47yq. So this was a challenging question. I would assume this is a challenging question. Let's try number 6. Number 6, I have to simplify. That's an easy one. The only thing I can simplify by factoring, assume that all expression and the radical represent non-negative number. X cannot be simplified because it's not x squared. 49 can be simplified because 7 times 7, 49. So this can be written as 7 times 7 times x, which is equal to square root of 7 times 7 times square root of x. I can separate radicals if it's a multiplication. What is the square root of 49? It's a 7 because 7 times 7 is 49. So the square root of 49 is 7, right? Sometimes you can think about it as 7 squared, and this is squared, so the square will cancel and you end up with the final answer as 7 square root of x. So here the 49 will simplify to 7, it comes out outside the radical as 7, the x will stay inside, and therefore the answer would be 7 and then square root of x. Let's try number 7. Simplify square root of 48t squared. Now 48 is nothing but 3 times 16, so 16 is a perfect square and will come out as 4. T squared is a perfect square, will come out as t. So here this is left with 4t, they will come outside, and inside the radical, again 16 has come out as 4, t squared has come out as t, so the only thing left is 3. And therefore the final answer is 4t square root of 3. Again, when you look at this 48t squared, notice that 48 is 3 times 16, and 16 is a perfect square that will come out as 4. Square root of 16 is 4. T squared is a perfect square because t times t is t squared, so t will come out. So the only thing left inside is 3, so 4t square root of 3 would be the final answer. Let's look at number 8. Again, we have to simplify the radical, and we have 1200. Now look what we can do with 1200. 1200, first of all, the 12 is 3 times 4, and 100 is 100, because 100 is a perfect square, will come out as 10. 4 is a perfect square, will come out as 2, so 3 will be left, and we still have y also will stay inside the radical. Now, do you agree that 12 times 100 is 1200? Yes. But now when I factor it into a perfect square, I know 4 is a perfect square, comes out as 2. 100 is a perfect square, comes out as 10. 2 times 10 is 20. Inside the radical would be 3y. So these two are perfect square. These will come out and will cancel. But 3 and y are not perfect square. They will stay inside the radical. So the final answer would be 20 square root of 3y. Okay? If you square this, 20 times 20, 400. Square this, 3y times 3, square root of 3y would be 3y, and 3y times 400 will give you 1200y. Number 9. Multiply and simplify. So here we have to multiply. We have 2 times 20, 10, which is 20, and b times b, which is b squared. Okay, so when you multiply radicals, you multiply the inside. 2 times 10 is 20, b times b is b squared. Now, but 20, remember that 20 is 4 times 5, and b squared, this is a perfect square, will come out as b. 4 is a perfect square, will come out as 2. So what is left? Only 5 is left inside. So this would be 2b square root of 5. So when I have 20, 20 is not a perfect square, but 4 times 5, 4 is a perfect square, b squared is a perfect square, b squared will come out as b, 4 is a perfect square, will come out as 2, so the final answer would be 2b square root of 5. And of course 5 is not a perfect square and will stay inside the radical. Let's try the next question here. Let's just multiply the whole thing inside the radical and then we can simplify. 2 times 4 is 8. Let's keep it as 2 times 4. You know why? Because 4 is a perfect square, will come out as 2. X squared y, and then xy 8. Alright, so you see that we have 2 times 4, x squared times y, and x times y. So I put them all inside the radical. Let me see which one is a perfect square. 4 is a perfect square, will come out as 2. X squared is a perfect square, will come out as x. Y is not a perfect square, x is not a... Oh, y8 is a perfect square, will come out as y4. Remember that y4 times y4, we add the exponents. That would be y8. So the square root of y8 is y4. So notice that this will come out, y8 will come out, and what is left inside the radical? 2yx. 2yx will stay inside the radical, and 2xy4 will come out. That would be the final answer. So again, 2 is not a perfect square, will stay inside the radical. Y is not a perfect square, will stay. X is not a perfect square, will stay inside the radical. But 4 is a perfect square, will come out as 2. X squared is a perfect square, will come out as x. Y8 is a perfect square, will come out as 4. And y8 is a perfect square because y4 times y4 is y8. We always add the exponent. So when you come back, y8, the square root of y8 would be y4, and that's why I pull out y4 outside. And so that would be the answer. 2x y to the power 4. Now we have a square root here, and 2yx inside the radical. 2yx are not perfect square and will stay inside the radical. Let's go to number 11. Divide and simplify. So we have square root of 3 over, what is 12? 12 is 3 times 4. Remember that 4 is a perfect square, will come out outside as a 2. So this would be square root of 3 over 2 square root of 3, right? Because 4 will come out as 2. The only thing left is 3. And square root of 3 and square root of 3 will cancel. So this would be 1 over 2. Remember, when the square root of 3 and square root of 3 cancel, it's not a 0, right? 2 will stay in the denominator. This is 1. Because remember, any number divided by itself is 1. So in this case, square root of 3 divided by square root of 3 is 1. But we have 2 in the denominator, so the final answer would be 1/2. Number 12. Here we have 64 is a perfect square. 289. Is 289 a perfect square? We can check. Alright, let's see. We know that 14 times 14. What is 14 times 14? 14 times 14 is 196. So we have to get bigger number. 16 times 16 is 256. How about 17 times 17? Let's try 17 times 17. 17 times 17 is 289. Okay, so this whole thing is a perfect square, so we can simplify the whole thing. 64 x squared over 289 is equal to, we can split the radicals, 64x squared divided by square root of 289. So the 64 is a perfect square, will come out as 8. X squared is a perfect square, will come out as x. 289 is a perfect square and will come out as 17. And the final answer would be 8x over 17. Eight x over 17 is the final answer. So that would be 8x over 17. Remember that if you multiply 17 times 17, that's a 49. 7 times 1, 7, and 4, 11. This is 7 and this is 1. So you end up with 9, 8, 289. So 289 is a perfect square, and the square root of 289 is 17. Of course, 64, 8 times 8, 64, and x times x, x squared. So 8x over 17 is the final answer. Number 13. Let's do number 13, and now we have to rationalize. This is 6 over square root of 5. Notice that 5 is not a perfect square. It will not simplify. So to rationalize, we're going to multiply up and down by square root of 5. Why we are doing this? The numerator will not simplify. It will stay like 6 square root of 5 when we multiply. But the denominator, you're going to multiply the inside. So that's going to be square root of 25. And of course, 25 is a perfect square and will come out as 5. And the final answer would be 6 square root of 5 over 5. Now, I did multiply by 5 because when you multiply 5 power 1 times 5 power 1, you add the exponent, this becomes 5 squared, and 5 squared is a perfect square. And square root of 25 will come out as 5, so no more radical in the denominator, and that's what we mean by rationalize. You want to remove the radical from the denominator. So this would be 6 square root of 5 over 5 as the final answer. 6 square root of 5 over 5 as the final answer. Let's try number 14. Number 14, we have two radicals. We want to add them because they have the same radicand, 6 and 6, exactly the same. We can add the coefficient, 6 plus 5, 11, and we keep the same radical, 6. So anytime you want to add radicals, if they have the same, they're like radicals, they have the same radicals, same radicand, 6, 6, you can add the coefficient 6 and 5. So this would be 11 square root of 6. So you would assume the square root of 6 as x. 6x plus 5x is 11x, but x in this case is square root of 6. Number 15. This time we have to subtract. But notice that they're not the same radicand. This is 63 and this is 7. So let's simplify. Notice that 63 is 9 times 7. 9 will come out as 3 minus 2 square root of 7. So if 9 will come out as 3, we will end up with 3 square root of 7 minus 2 square root of 7. And if it's 3x minus 2x is 1x. So 1 square root of 7 or square root of 7. We don't have to put 1, we just put square root of 7. So notice here, because these were different radicand, the number inside the radical, they're different, I had to simplify the square root of 63, which is 9 times 7. 9 is a perfect square, will come out as 3. So instead of square root of 63, I can write 3 square root of 7 minus 2 square root of 7. Now we have the same radicals. Square root of 7, square root of 7. I can subtract 3 minus 2, which is 1. But we don't have to put 1, we just put square root of 7. Number 16. On number 16, again, I have to make all these the same radicand so I can subtract or add. What can I do with 8? Square root of 8 is 4 times 2. So the 4 will come out as 2. Plus square root of 50 is 25 times 2, and the 25 will come out as 5. How about 18? 9 times 2 and the 9 will come out as 3. So look what happens now. 9 times 2, 18, square root of 2, plus 5, square root of 2, minus 3, square root of 2. So I had 9 square root of 8. Remember, the 4 will come out as 2, so this 4 will cancel. 2 times 9, 18. I'm left with 2 here. 18 square root of 2. Here we had a 50. The 25 will come out as 5. There was nothing here, so 5 times 1 is 5. I'm left with 2, 5 square root of 2. Here I have 18, 9 times 2. 9 will come out as 3. Now notice I have the same radicals. I can add the coefficients. 18 plus 5 is 23. 23 minus 3 is 20. Square root of 2. Final answer. So now we have 18 square root of 2 plus 5 is 23. 23 minus 3 is 20 square root of 2, and 20 square root of 2 is the final answer using radicals as needed. 17. Do the same thing here. We have 18. Again, remember 18 can be written as 9 times 2. So 9 will come out as 3 minus 32 can be written as 16 times 2. So the 16 will come out as 4, and then 8 can be written as 4 times 2. 4 can be simplified to 2. So what is 2 times 3? 6 square root of 2. 3 times 4. 12 square root of 2. 3 times 2. 6 square root of 2. Notice that, of course, when 9 comes out as 3, it will simplify. When 16 comes out as 4, it will simplify. And when 4 comes out as 2, it will simplify. So the only thing left, you see, it's only 2 left inside the radical. 3 times 2, 6 square root of 2, minus 3 times 4, 12 square root of 2, 3 times 2, 6 square root of 2. Notice that 6 square root of 2 plus 6 square root of 2 is 12, minus 12, 0. So the final answer here is 0. All right, let's submit the quiz. Oh, we did it right. Good. All right, so good luck, everybody.